Now the rectangles we're gonna look at examples with these rectangles. And my first one is right here. We want to find the value of x, and we know the length of segment AC. Well, it's not even in there, so I'm going to draw it in. We know the length of segment AC is this 6x plus 4, and we know the length of segment BD, which is not in there, but I'm going to draw it in so we can see it, is 7x minus 4. Well, think back to our properties of a rectangle. We know that the diagonals are congruent, which is going to tell us that the lengths of those two diagonals are going to have to be equal. I've written that my two diagonals are equal in length. Now it's just a matter of solving the equation, and I will have found my value of x. I'm going to subtract 6x from both sides, and I'm also going to add 4 to both sides, which gives me x equal to 8. And for this one, that's all the farther it asks us to go. Now sometimes it may ask you to actually find the length of the diagonals, and then it'll just be a matter of taking that 8 and plugging it back in. You can take it over here into the 6 times 8 plus 4, you have 48 plus 4 is 52. Or come over here, 7 times 8, 56 minus 4 is 52. A little check of my work, and I see that it worked out wonderful. Next, this one, taking a couple different things, a little bit of the old, a little bit of the new, we're going to put them together. Now in this one, notice the y squared minus 1 is this angle, and the 4y plus 4 is this angle. And we want to figure out what is the value of y. The way I'm going to look at this is I'm going to look at it in terms of this triangle. Being it's in a rectangle, I know I have the one right angle, and then my other two angles are the ones that are marked. Well, if one angle in a triangle is right, the other two have to be complementary, which is going to tell me that this and this added together has to equal 90 degrees. Now you're looking at that going, we haven't seen that kind of equation very often, and you're right. It is an equation that you've solved before. It's a quadratic because we have a squared variable, and our way to solve that, hiding under here underneath my hint, we can use the quadratic formula. Now to do that, first we have to get one side equal to 0. I think it's easiest to get the right side equal to 0 in this case. And then I'm going to put it in descending order, meaning my squared variable is going to go first, followed by the variable with a degree of 1, so the 4y, that's the only one with a y. So y squared plus 4y, and now I have the 4 minus 1 is 3, minus 90 would put me at negative 87, equal to 0. I have it in descending order. Now I can use my quadratic formula, plug everything in. So in this case, now over there I know it says x equals because my variable in that equation was x, but mine is y. So I'm going to do y is equal to, now, negative b. The b value in my case is 4, plus or minus square root of b squared. Well, b is 4, minus 4 times a, which is 1 in front of the y squared, times c, which is negative 87. And that's all over 2 times a. There we go. Our answer's right there. Now it's just a matter of simplifying it, making it look a little prettier is the way I think of it. So I'm just going to go through and simplify my big mess here. 16, and this is going to be minus a negative 348 all over 2, which really is plus 348, another way to look at it. Now I'm going to have negative 4 plus or minus the square root of 364 all over 2. Now what I'm going to do at this point in time is I'm going to take the square root of that 364, and we could simplify it, keep it in, radical format, but what I'm going to do is I'm just going to punch it on my calculator. The square root of 364 is approximately 19.08, and we'll divide it by 2. And then this is where I'm going to take this and I'm going to break it apart into the two different expressions that are there. One's going to be the negative 4 plus 19.08 all over 2, and then the other one's going to be the negative 4 minus 19.08 all over 2. And then when I do that, this first one comes out to be positive 7.54, and my second one comes out to be negative 11.54. So it appears that I have two answers. So y is going to equal this, and y is going to equal that. Now we've got to come up and ask ourselves, do they both make sense? Come back to my original problem. If I go with the negative 11.54, I'm going to check that one first, and I'm going to think about this one. If I take 4 times negative 11, and I know it's a negative 11.54, I'm going to be at somewhere around negative 44. Add 4, I'm at negative 40. Now, does it make sense that an angle has a negative measure? No, it doesn't. So I can rule out the negative 11.54 for that reason. I could also come over here to this one. If I take negative 11.54 and square it, even a negative 11 squared is 121. 121 minus 1 is 120. Does it make sense that this angle up here is 121? Well, no, it doesn't, because remember, go back to my right triangle. I already had one right angle in it. If one angle is 121 and the other one's 90, it's not even going to be a triangle. So that negative 11.54 does not make sense in this problem. It made sense in the equation, but not in the rectangle that it was in. Therefore, this one would be my only answer. Now my next one is, I want to know, is this thing a rectangle? So I'm going to start like I did the other day with a problem like this. I'm just going to put a rough sketch of it out here. Negative 2, 1, there's my A value. I have 4, 3, there's my B value. C is at 5, 0, it should be out here somewhere. And D is at negative 1, negative 2. So is this thing that I have drawn a rectangle? Based off the way I drew it, it doesn't really look like it, but we're going to figure it out. Now we have a couple things to do. One, we could look at that property that we had today that said if a parallelogram, if the diagonals of a parallelogram are congruent, then it's a rectangle. Now if we did that, first we'd have to figure out, is this thing a parallelogram? And then we'd have to look at the diagonal lengths, which we could using distance formula, and we'd have it. Now I look at that, and that's kind of a long, tedious process. So I'm just going to go back to our definition of a rectangle. It's a quadrilateral with 4 right angles. So if we could prove that angle A, angle B, angle C, and angle D are right angles, we'd have it. And the way I do that is I'm going to look at slopes of the sides of this quadrilateral. If the slopes are opposite reciprocals for consecutive sides, I know I have a right angle, because that means that they're perpendicular. So that's what I'm going to do. I'm going to look at the slope of all 4 sides. I'm going to start with the slope. I'm going to start with segment AB. I'll do my slope formula. Here I'm going to have 3 minus 1 be my A values, and then 4 minus negative 2. End up with a slope of 2 over 6, or 1/3. So my slope up here is 1/3. I'm just going to go to the segment BC then. Check the slope on that. So I have the slope, segment BC now. Now I'm going to do 0 minus 3, and then 5 minus 4. Here I have negative 3 over 1, which is 3 for a slope. And I have that one. Let me fix this. Forgot the negative sign there, negative sign there. Now I look at my two slopes. Positive 1/3, negative 3, those are opposite reciprocals. Therefore, I know this has to be a right angle right here. So I have one right angle. And some of you are going, well, Mr. Rude, we can stop right now, because if a parallelogram has one right angle, then they're all right angles. Well, the problem is we don't know if this is a parallelogram yet. So we're going to have to continue on. Next, I'm going to go to the slope of segment CD. Go ahead and calculate that. So I'll do negative 2 minus 0, and then negative 1 minus 5. Just going to put me at negative 2 over negative 6 for a slope of 1/3. And I would say this is looking more and more like a parallelogram. I now see that I have one set of opposite sides that are parallel. I also look here at this slope and this slope. Well, opposite reciprocals, therefore those two segments are perpendicular, which means I'm going to have a right angle there. Now it's just a matter, is angle A and angle D, are those right angles? I can figure that out doing one more slope. So now I have to find the slope of segment AD. Do my y value at D minus my y value at A, and my x value at D minus my x value at A. Oops. That wouldn't be a -3 though. Oopsie. Hitting the wrong buttons, I'm sorry. Let's get a pink, so minus -2. There we go. This is going to give me -3 over +1, which is -3. There you go. Comparing my slopes here, opposite reciprocals, where that's a right angle. Compare my green and my pink, opposite reciprocals. Look at that, I have 4 right angles. So is this thing a rectangle? Yes, it is. It's a quadrilateral with 4 right angles. And then that's where I'm going to finish my examples dealing with rectangles.